All right, in this video, we're going to go over key features of quadratic functions. This is Module 10, Lesson 6 for my students. All right, so here we're looking at a quadratic function, and we're going to list the key parts of a quadratic graph. So this here, first of all, is called a parabola, not a parabola, but a parabola. And this actual parabola has a vertex. So with this vertex, because it is a negative function, meaning the parabola is opening down, it has a maximum. So this maximum value, if we're looking, is when we have an a that is less than 0, meaning our a is a negative number. Okay, so if we're looking at a quadratic function here in a moment, if our a is negative, the parabola will be opening down and we have a maximum. So first we're going to take a look at our x value. So the x value of our vertex is usually the amount of time it takes to reach a maximum height. The y value of our vertex is the actual height that the object reaches. So the maximum height of the object or the function. Okay. If you have an a term that is greater than 0, so a positive number, then we're going to have a positive function because the graph or the parabola is going to open up. If we have a positive function, we actually have a minimum. Our vertex is our minimum. So it's a little bit different. Instead of having a maximum, like this one did, we would have a minimum. And that, again, is when our a is greater than 0 or when we have a positive a. Then here is where our y-intercept is. So this here is our y-axis. This is our y-intercept. That is where the graph or the function is crossing the y-axis. This is our c term if the function is in standard form. This is also the initial value or the starting point for our function. Then we have the axis of symmetry. That's what cuts our parabola in half. So if we folded this parabola in half, these would be perfectly symmetrical, which is why it's called the axis of symmetry. So that's the vertical line that passes through the vertex. And we can find our axis of symmetry by a formula that is x is equal to negative b over 2a. So this formula, negative b over 2a, is part of our quadratic formula. And we'll use that to find our axis of symmetry starting in our Module 10 Lesson 7 notes. This part of the graph is where it's increasing. So from left to right, the graph is increasing on this side. So we would list that as x increases, y is increasing. So mathematically, that would be x such that x is less than 1. So when our x values are less than 1, okay, the function is increasing. And on this side, the function is decreasing because, again, as my x values are increasing or going up, now my y values are decreasing or going down. So we could write that as x such that x is greater than negative 1. So when my x values are greater than greater than 1, then the function is decreasing. Now these here are what we talked about in all of Module 10's lessons 1 through 5. These are our x-intercepts, also known as our roots, our solutions, or our zeros, okay? Those all mean the same thing. This is our negative x value on this side of the parabola. Okay, so in this example, it's negative 1, negative 1.5, and 0. And a lot of times this is an invalid solution when we're applying it to a real world because we can't have negative time. Now this here is our positive value, x value. So in this example, 3.5 and 0. So this would be a valid solution. And this tells you how long the object was in the air. It does not tell you the distance that it went, but it tells you how long the object was in the air. So those are all the different key parts of a quadratic function. And now we're going to practice identifying those key parts when we're given an equation and the graph. Okay, often you're only given the graph or the equation, but in these first few examples, just as we're getting used to it, I'm going to give you both. So first, let's do a quick review of domain. Domain is all of the possible x values for a function. The range is all of the possible y values for a function. So what domain and range of this function is appropriate for the context? That is a very common question that you'll see when we start applying our parabolic functions, our quadratic functions, to the real world. So the domain of this function, we have x squared minus 2x minus 8, and they graph the function for us. So all of the possible x values here are going to be all real numbers. So this fancy r just means all real numbers. Now the range for this function, that's our possible y values. So you'll notice that the parabola goes all the way down to here. This is its minimum, and then starts going back up. So we will not have any y values below this point. So we have to find the value of that point, which is our vertex. And in this case, it is 1, -9, okay? So that means our range must be any number greater than or equal to -9, okay? This function, because it has a positive a and is opening up, notice that the a here is greater than 0. All right, this side of the function is where it's increasing. So this would be x is greater than 1. Again, we're going to relate it to our x value of our vertex. The function is decreasing from left to right on this side of the parabola. So that is when x is less than 1. Then we have our axis of symmetry. That's the line that cuts our parabola in half, and our axis of symmetry is x is equal to 1, but we can also find that mathematically by plugging it into our formula, negative b over 2a. So negative 2, because our b is -2. So that would look like this. We have a negative 2 over 2 times a, which is 1. So this is going to simplify to be 2 over 2, which is 1. Because starting tomorrow, or starting on our next set of notes, we are not going to be given the graph. We have to graph it ourselves. So we have to be able to find it using the formula and using our function. Our vertex we already labeled as 1, -9. Now we're going to identify our y-intercept, and our y-intercept is right here at -8, but you can also look right here at the number, the c term in our quadratic function, which is -8, so our y-intercept is 0, -8. The zeros of this function we can identify just by looking at the graph. Okay, this is our x-axis, so that's when x is equal to 0, -1, -2. And then we also have an x value over here, 1, 2, 3, 4. So that's 4, 0. But then we can check our math by plugging it into we can plug this function into the quadratic formula and simplify. Now, for some odd reason, it is cutting off the bottom, and I'm sorry, but there's not much I can do about that right now. I'll deal with it later. All right, moving on. We're going to do one more graph. So again, here I do want you to pause and try it on your own first, and then just come back and check the video to see if you were right. But our domain here is still going to be all real numbers. Our axis of symmetry we can find by doing negative b over 2a. So negative b, or -5, divided by 2a. So -5 over 2 multiplied by -1 is going to be simplified to be 5 over -2, which is going to be -2.5. So the first number in our vertex is going to be -2.5, and then we have to find the y value. Well, you could estimate the y value, but better yet, let's plug in this x value that we found for our axis of symmetry. We're going to plug it into our x in the equation that was given to us, in the function that was given to us, and evaluate it. Remember, we did this back in Module 2. So we can plug this all into the Desmos calculator. We're going to have a negative parentheses, negative 2.5 squared, minus 5 multiplied by negative 2.5 plus 1. And when we do that, we get f of x is equal to 7.25. So now we know that the vertex of this function is 7.25. So we can now determine our range of this function, which is any y value that is less than 7 or equal to, less than or equal to 7.25. This function is increasing from left to right here on the left side. So that's when x is less than negative 2.5. And it is decreasing when my x values are greater than negative 2.5. The y-intercept here, we can either look here at our function, which is positive 1, or we can look here at the graph, and again, we see it's positive 1. So our y-intercept is 0, 1. And then we can find our zeros. So to find our zeros, you are going to plug in these numbers into your quadratic formula, and you're going to get an approximate answer. So when you plug this into the formula, you're going to have a negative 5, because it's negative b, plus or minus the square root of b squared, so negative 5 squared, minus 4 times negative 1 times 1, all over 2 times negative 1. So that simplifies to be 5 plus or minus the square root of 29 over negative 2. So we're going to put this into the calculator, 5 plus the square root of 29 over negative 2, which is approximately negative 5.19. And then 5 minus the square root of 29 over negative 2, and we get approximately 0.19. These little wavy lines means that we're approximating. It's not the exact answer. This is our exact answer, but this is an approximation. This is a decimal. All right, now you're going to try the practice on your own. These practices are a bit easier than that last try on your own because they all have clear numbers for their x-intercepts, their roots, or their zeros, with the exception of this one maybe. All right, so go ahead and try this and let me know if you have any questions in class.